All right, so let's move on. Again, hang on. How come it's not moving? Let's try. This is the National Day's promotion. So sharing is caring. So do share 88 tuition with family and friends. So you can share with them the 88 tuition handphone number. And then all of you will have your own special referral code. So your friend will have one free live lesson. They get 25% off if they choose to subscribe. You also get 25% off. So it's a win-win situation. So we have primary 3, primary 4, primary 5, primary 6, set 1, set 2. Next year, we will also have set 3. All right. So please do share with as many people as possible. All right. Okay, we have one more person coming in. Okay, hi, Raga. Is it, do I pronounce your name correctly, Raga?
Yes, ma'am.
Okay, is this your first lesson with me? I'm Miss Ivy.
Yeah, it's my first lesson.
Okay, well done. All right, welcome, not well done. Okay, let's start now. Now, first question. Now, the following diagram, okay, for the case of Rahaf, is it pronounced as Rahaf or Raga? Raghav. Okay. Raghav. All right, Raghav. Welcome again. Now, because you missed the rules just now, so I just quickly tell you, feel free to type in the chat if you have any question to ask Raghav. And then if you need to go toilet, don't need to ask for permission. Just type in the chat, I'm going toilet. And when you're back, you just type, I'm back. All right, so feel free to type in the chat anything that you don't understand. I'll be using the chat often. All right, so this one is a reverse osmosis plant. All right, so they are asking you, all right, after which part of the plant does the concentration of salt in water change? Okay, so first of all, this word reverse osmosis, I want to check with everybody. Reverse osmosis, does it involve a semi-permeable membrane? Can you answer my first question for today? Is there a semi-permeable membrane? Thank you, Anlak. Thank you, Arjun. Yes. Well done, Kirana. Okay. So there is a semi-permeable membrane. So let me write it very quickly. So as long as you see the word osmosis, it must involve a membrane. All right. And then the word osmosis tells you it is the movement of what? Who is moving? Can everybody type in the chat? Is it water moving or solute moving? Who is moving when you use the word osmosis? No worries. All right. Please travel safely, Sheena. All right. Yes, on your way home. All right. So be very careful. Don't need to rush. Okay. You can always watch back the video recording. Safety first. Raghav, good try. All right, but there's a concept error. Now, don't worry about giving me the wrong answer. I'm very happy to have an answer. All right. So it's nothing shameful about getting the wrong answer. You just learn. After today, no more mistake. All right, Raghav. Okay, so the rest of you, is it movement of solute or movement of water? For the word osmosis. Quickly, can we have responses, please? Kirana, thank you for responding, but also same conceptual error. Zainab, also same conceptual error. All right, but good try, everyone. Wesley, I'm asking movement of solute or movement of water? You choose solute or water. That means movement of solute or movement of water. Okay, good job, Wesley. All right, sure. All right, excellent answer, Wesley. The rest of you, I don't have a response from you. Anlak, where's your answer? Aaron, where's your answer? All right, Bernie, where's your answer? Zixuan, I still also don't have an answer from you. All right, so osmosis is definitely talking about water. Water moving, not solute moving. All right, so let me highlight for you, very important. So I'm going to highlight in yellow. So if you have the word osmosis, you must talk about water, not solute, not sugar or salt. All right, Aaron, I'm not asking for the answer. I'm asking osmosis, who is moving? Is it water moving or solute moving? All right, so the answer is water moving, okay? And then osmosis must involve a membrane. It must involve a semi-permeable membrane. So these two is very, very important. So I put a star. Osmosis is water moving, not solute moving. Solute will be, for example, sugar, salt. There are many solutes in the world. Solute is something that dissolves in water, and it involves a semi-permeable membrane. All right, so please remember these two things. Okay, so after which part of the plant does the concentration of salt change? All right, so the answer is, now everybody type your answer into the chat, A, B, C, or D. At what stage will the concentration of salt change? All right, so basically in desalination plant, Singapore has 5 desalination plant. All right. We basically use reverse osmosis. All right, to change seawater to pure drinking water. So we are changing seawater, which is so salty. We can't drink seawater, we'll die. We are changing seawater to pure drinking water. So that is what desalination plants do. So Singapore has 5. All right, Singapore has 5 desalination plants. So seawater change to pure drinking water and using reverse osmosis technology. All right, so that is the meaning of desalination plant. So the answer is actually D, is because at the membrane, right? This membrane means a semi-permeable membrane. All right, so at the semi-permeable membrane, we are using a lot of energy, all right, which is high pressure, to force the water molecules, the Mickey Mouse water molecules, through the membrane, through the semi-permeable membrane. All right, so we are forcing water through the membrane, and therefore, once water is moving to another place, then the concentration of salt in the water will change. All right, so because water is moving away from the seawater, okay, so inside the seawater, you have salt plus water. All right, salt is too big, too fat to go through the semi-permeable membrane. Water molecules are very small. They can pass through the semi-permeable membrane. So the water will say bye-bye to the salt. All right, so water gets separated out into the pure drinking water. All right, the salt will remain behind. Salt cannot pass through the membrane. All right, so therefore the concentration of salt will change because you are separating the salt and water. So the answer is D. Okay, so these are just some extra information for everyone. In the desalination plant, there are 3 processes: pre-treatment, reverse osmosis, and post-treatment. So pre-treatment means once they have the seawater, seawater, ocean water got so much rubbish. So they must first remove all the rubbish, the debris, and even remove the germs, the microorganisms, or even the silt, which is actually like a fine sand, something like sand or mud, all right, silt. So they remove all these big items first, all right? Then after that, they go through reverse osmosis, which uses a lot of energy to force the water molecules through the semi-permeable membrane, all right? Then post-treatment, they will add minerals like calcium. They'll add calcium or they'll add fluorine into the water, all right, to sanitize the water. So there are 3 stages in the desalination plant. Okay, so this one is just a quick one. I have gone through this for those of you who are staying with me for quite some time. So diffusion, solute is moving. Osmosis, water is moving. All right, and osmosis involves a membrane. The water molecules will pass through the semi-permeable membrane. Diffusion got no membrane one. All right, so that's the main difference. Okay, now there's something called higher water potential and lower water potential. Instead of using water concentration, they use the word water potential. All right, so just take note that when we have more things dissolved inside water, let's say you add more sugar in the water, the sugar, right, will stick to the water. So if you add a lot of sugar, then the sugar will bind and stick to a lot of the water molecules. Then there'll be less water molecules to move freely. Freely means with the freedom. So if you have a very sweet solution or you have a very salty solution, very concentrated solution, a lot of the water molecules are trapped by the solute. A lot of the water molecules are trapped by the sugar that is dissolved. A lot of the water molecules are stuck to the salt or sugar that's dissolved. It will be lower water potential. All right. So this is I explain using this. All right. So if you have, for example, a very dilute solution compared to a concentrated solution. So let's say you have 100 water molecules. And then you have 10 sugar molecules. Now these 10 sugar molecules are dissolved in the water. So remember, 10 sugar molecules will stick to All right, actually it's bind, stick to 10 water. Right, imagine 1 sugar stick to 1 water lah. So 10 sugar will stick to 10 water. So therefore 100 minus 10, you will only be left with 90 water molecules which have the freedom to move. Free means freedom to move anywhere. All right, freedom to move, not in the prison. All right, compared to a concentrated solution, you have 100 water molecules, you have 40 sugar molecules. So these 40 sugar molecules will stick to, can someone unmute yourself and tell me stick to how many water?
6.
If you have 40 sugar dissolved inside the water, then how many water molecules are stuck to the sugar?
60. 60.
No, assume 1 sugar will stick to 1 water. Every 1 sugar will stick to 1 water. So if you have 40 sugar, you will stick to 40 water. Do you follow so far? You will stick to 40 water. 40 water molecules. Then 100 minus 40 will be 60. So you have 60 water molecules with the freedom to move. Do you all follow so far? All right, freedom to move. Okay. Then now you compare, all right, this one, 90 and 60. All right. So therefore, this is what I call higher water potential. Instead of using water concentration, all right, it is like concentration, but a better word is potential. All right, so here will be lower water potential. Well, 60 is a smaller number compared to 90, right? So lower water potential, higher water potential. Can everybody type in the chat? How will water move? Will water move from left to right, or will water move from right to left? Can y'all type in the chat left to right or right to left? I give you 5 seconds to type. L. Will it move from L to R or R to L? Okay, well done. Raghav. Hope I pronounce your name correctly. Arjun,
Yeah.
wrong correct. Raghav. Arjun, wrong concept. Not wrong concept. Zainab, well done. Aaron, well done. All right. So boys and girls, it's okay if we get this wrong this time around, but please remember, just like a waterfall, things will always move from a high to a low place, a high place to a low place, right? Water will fall down. You will not see water going upwards, right? Water always go from high to low. Therefore, the water movement will be this way. All right, because 90 is a bigger number. All right, so water move this way. Water molecules moves. All right, from, in this case, is left to right. Why left to right? Because from higher water potential to lower water potential. All right, higher to lower water potential. So instead of saying water concentration, I use a special word, water potential. Okay, so let me highlight for you here. So higher water potential move to lower water potential. All right, so this is higher, this is lower. Why higher? 90 is a bigger number, 60 is a smaller number. All right, 90 bigger numbers are higher water potential. So imagine you got 90 free people, they are free to move. Here only 60 people free to move. Here got more, so the water will move this way. The net movement will be from left to right. Is everybody clear? So that is osmosis. All right, so osmosis is water moving, not sugar moving, not salt moving, not solute moving, it's water moving through a membrane. All right, through a membrane. So everybody clear? So water is actually moving from 10% sugar solution to 40%. So I'm going to write here this way. 10% sugar, 40% sugar. The movement, right, is actually this way, which is the same as my arrow here. All right, so water moves this way. So some of you, right, you thought that it's lower to higher is because you were thinking of this 10%.